understanding from the principal that this will be handled, EOC testing will be handled by your home zone school, that we here at Hospital Homebound won't be administering the tests. So I'm sure you'll be contacted about that as to when and where and all that kind of good stuff. I know a lot of schools are doing it this week, but if you haven't heard anything this week, then you're probably not doing it this week. So, but I wanted to go ahead and get started and do some EOC review for you guys to help you out. Pass that test so you can go graduate and enjoy yourself getting out of school, right? All right, so let's go ahead and pick up where we left off. We got quite a bit done the other day. And the other day being yesterday, I guess. That I don't know. I don't. Typically, it's online, but you have to like go somewhere to take it. But again, like I said, this is something that your home zone school will deal with as far as whatever accommodations you might have and things like that. So, but it is a graduation requirement, so I'm pretty sure you're going to have to do that. All right. So it looks like I brought up the wrong one where I haven't written on it yet. So let's see, what did we do? We did that one. We did that one. And we did that one. So like I said, we did quite a bit of them. Okay, I think this is where we're at. Yeah, this looks good. Okay, so we'll start with this one. So it says the domain of this function is given as -2, -1, 0, 1, 2. What is the range? Okay, so domain. When they ask you for the domain, they're asking you for which? Are they asking you for the possible x values or the possible y values? So that's the biggest thing. Is first things first, we have to know the difference between the domain and the range. So domain, is that going to be x or y? So is the domain the possible x or the possible y? Good. And if you get confused, just remember it's alphabetical. So x comes before y, right? So domain is x, except this thing is not writing. One moment, please. So domain is x and range is y. Okay? So d comes before r and x comes before y. So that's one way to keep it straight. Because back in the old days, for some reason, we used to say range and domain. We used to say it backwards. And I'm not really sure why, but we did. It took me a long time to sort of get used to saying domain and range, because that's not how we said it back in the ancient times. Okay, so you probably heard me say this a few times. This says f of x equals this stuff, right? So f of x. So you've probably heard me say this a few times. F of x is a fancy version of what? What is f of x a fancy version of? I feel like I say this 3 or 4 times a day. Yeah, it's a fancy version of y. And I talk about drilling stuff into your head, right? So this is really just y equals 13x minus x squared. Okay, so if we're looking for the range, that means we're looking for the possible y values. And we've been given the possible x values. These are x values, right? So the moral of the story is we're just going to plug each of these values in here wherever we see x, come up with a y value, and that will be part of the range. Make sense? All right, so we'll put the range down here and we'll do some calculations. All right, so range, and then we're going to get some points, right? And since we have 5x points, we should get 5y points. Okay? So for the first one here, we're going to have 13. And then we're going to plug in a -2. And then minus -2 squared. Okay? So the first one we have 13 times minus 2. So that'll be minus 26. Right? And then we have minus, and remember when you do a negative number and square it, negative 2 times negative 2 is a positive 4. But we still have this minus sign to deal with, right? So this would be another minus 4. Okay. So then what we have to do is we just say minus 26 minus 4 more is minus 30. So when x equals negative 2, y is going to equal minus 30. So that's our first point. All right, so next one, we're going to go ahead and plug in negative 1, right? It's just going to be the same thing. So we're going to have 13, and then times minus 1, and then minus 1 squared, right? So then we're going to do 13 times negative 1, that's negative 13. And then we're going to do minus 1 squared is going to be positive 1, right? But then we still have the negative sign out front. So that'll be minus 1 more. So minus 13 minus 1, minus 14. So that'll be our second guy. Okay. So the next one, if I plug in 0 wherever I see x, what's my answer going to be? I'm going to put in 0 where I see x. Yeah, because everybody has an x term. If you plug in 0, everybody just goes to 0. So that one's easy. We didn't even have to do anything for that, really. All right, so there's our third one. Cool. All right, so next one we've got 1. Let's change up here again. So then we're going to have 13 times positive 1, and then minus 1 squared. So this time it's 13 times 1, that's going to be a positive 13. And then minus 1 squared is still 1, so minus 1. So this guy's going to be positive 12. So it's going to go there. All right, and then we got one more to do. So let's check out one more here. So this one's going to be 2. So we're going to do 13 times 2, and then minus 2 squared. All right. So 13 times 2, that's going to be 26. And then 2 times 2 is 4, but it's going to be minus 4. So 26 minus 4 is going to be 22, and that's going to be our last guy. Okay. Now again, they would probably do this as multiple choice. And if they do it as a multiple choice, you can probably get to your answer a lot faster. You wouldn't necessarily have to do all these steps. But if it does turn out that you have to come up with your own numbers, this is what we would have to do. Okay. Any questions on that one? Pretty easy? Okay. And that's what you're going to find with the EOC. A lot of times, the questions themselves aren't very hard once you figure out what they're actually asking you. That's the hard part usually. It's like, what are they asking? Because they ask stuff in weird ways, don't they? So that's what we're trying to do here by doing this review. I mean, most of the steps you know how to do. It's just a question of finding out what is it they really want from me. So if we can kind of decipher that and get you used to their weird lingo, then we'll be in good shape. All right, so let's go ahead and check out another one. All right, so it says, which of the following inequalities have the solution shown in the graph? So which of the following inequalities? So this means could be more than one. All right. So here's a way you can do this. This is a good hack on this one. So we pick a point. Let's pick an easy point. Let's pick 0, 0. Okay. Now notice that 0, 0 is not part of the answer, right? So why would I pick 0, 0? Well, there's a couple reasons. Like I said, this is a good hack. I would pick 0, 0 because, first of all, it'll be easy to solve. And secondly, what we're looking for here is we want it not to work. If it doesn't work, that means it does work up in here someplace, okay? But it'll be a lot easier to kind of get to where we're going. All right. So let's try that. So that means if I plug in 0 here and 0 here, right? Then the whole thing just becomes 0. So I have 0 is less than 40. Is 0 less than 40? Yeah. So this is a true statement, but we're looking for a false statement here, because rather than pick a point up in here, because that would be more work. You know, like if I pick like 6 minus 5, that would be a lot of work. And then we'd be looking for true statements, but we can look for false statements here and still get where we want to go. Because that was always the thing when, you know, sometimes they would talk about doing this stuff and deciding which side of the equation to shade on or which side of the line to shade on. So sometimes they say, well, pick a test point, and if it works, that's the side you want to shade, and if it doesn't work, you shade the other side. So we're looking for a point that doesn't work, and in this case, that's 0, 0. Okay, so the next guy. Again, if we plug in zeros here, all right, we're going to get 0, and 0 is greater than 40. So is 0 greater than 40? That's okay, Taylor. We've all had our Y problems. So yeah, 0 is not greater than 40. So that means this point does not work, which means the points up in here do. So which of the following is a solution? Well, this guy is. Okay, so that one's good. All right, so the next one. So if we plug in a 0 here and a 0 here, we're going to get 0 is greater than or equal to, and then this will be 0 plus 10, so it's 10. All right. So is 0 greater than 10? No. So that means that 0, 0 doesn't work. That means the stuff over here does. So this would be another one that would be one of our answers. Okay. So we'll check out the next guy here. So again, if we plug in 0 here and 0 here, we're going to get 0 is greater than 10. Okay. So how about that guy? Is 0 greater than 10? So that's another one that works. And if you notice, C and D are pretty much the same, except this guy's got the or equal to here. Ah, which brings up a good point. No, that's okay. It's cool. I was thinking something else, but it's cool. Okay, so then this guy, same deal. We plug in a 0 here and a 0 here, so we're going to get 0 is less than or equal to 80. Now, is that true? Is 0 less than 80? Okay, so that means 0, 0 works. That means it's not up in here. So that guy doesn't work. And then we look at the last one here. We plug in 0 and 0. So we get 0 is greater than 80. Now, is that true? Is 0 greater than 80? No. So that's one of our answers too. So we've got 4 answers on that one. Okay, so again, what we did here, like I said, this is a little bit of strategy. We said, I'm going to use 0, 0 because it's an easy point to plug in. You saw we did that pretty quickly, right? And then we also said, well, that's not part of the solution because, again, the solution was up in here, right? So if it comes up to be false, then that has to work up in here. So we were actually looking for false statements. That's kind of unusual, but that's how it works out, okay? But that's an easy way to do that one, okay? So in these, I would always pick 0, 0 because it's easy to plug in because it pretty much just turns everything into 0 that has an X or a Y to it, right? And then again, if that is included in the shaded part, you'd be looking for true statements. If it's not included in the shaded part, as we have here, you'll be looking for the false statements. Does it make sense? All right. So again, I'm just trying to give you guys a little bit of strategy for this kind of stuff, because a lot of taking tests like this has to do with strategy. It's not necessarily what you know, it's how you apply the information. All right, let's check out another one. Okay, so it says, what must be done to f of x equals the absolute value of x to obtain this function here? All right, so let's break this down a little bit. And by process of elimination, we can figure out what's going on. Okay, so let's start with the number, the negative 10. All right. If we just tack on a number and it's a negative number, how does that move our graph? Up, down, left, right, stretch, compression. What's that do for us? If we just have a minus 10 at the end of the function, what's going to happen? No. The left has to be in with the x, so that would be the stuff going on in with the x plus 4. But let's do that then. Let's talk about that. So that would move this part here, right? That would move you to the left 4. So let's look at our answers. So shifted left 4 units, he's still in. Shifted right 4 units, no. Shifted left 4 units, he's still in. Shifted left 4 units. So we got rid of 1 that way. Now let's go back to the 10. So if that moved us left and right, what does the 10 do for us? What's the negative 10 do for us, actually? Yeah, going to move us down, right? So we're going to go down 10 units. So shifted down 10 units. So this one's still in, right? Shifted down 10 units. This guy's still in, right? And this one's shifted up 10 units. So this guy's out. All right, so we got rid of 2 of them. Okay, so then the last thing we have to look at is the 0.5. So the 0.5 out front means our graph is going up half as fast. Now, if you're going up and down, but only half as fast, is up and down vertical or horizontal? Which one is that? You don't have to write the whole thing out. You can just say H or V. So is vertical up and down, or is horizontal up and down? Which one is it? So horizontal is actually left and right. So that's not our guy. So this one says horizontal. This one says vertical. So this is not our guy. Okay, so vertical is up and down. So that would make that our guy. So see how we just do that process of elimination. And even if we ran out of steam at that point and we had A and C, you know, if you have a 1 out of 2 shot at the problem, that's a lot better than a 1 out of 4. So again, the guy on the end, so the minus 10 moves you down. The plus 4, since it's in with the X, moves you to the left. And then the 0.5 would make our graph like a wider looking V as opposed to like 1, which would be more like this. Okay. So that would be vertically shrunk. And that's the weird part, because normally we don't say shrunk, we would say it's a vertical compression. So they're kind of being a little tricky with that one. All right, but that's the kind of stuff we're trying to avoid for you guys. So just think shrunk means it's going to be smaller, it goes up slower. Okay, so that's kind of what we're going for there. Any questions? All right, let's go ahead and check out a couple more. So it says the resulting polynomial when 3x plus 7, so 3x plus 7 is multiplied by 2x minus 6. Okay, so the first things first. If we FOIL this guy out, are we going to get 2 terms or are we going to get 3 terms? What do you guys think? Yeah, we're going to get 3 terms. Now, here's the thing. You don't need to multiply this whole thing out to figure out where we're going, right? So we're thinking, okay, we're not going to get 2 terms, we're going to get 3 terms, because we are going to get an x squared, right? By multiplying the first terms together. So we can cross these guys off. Cool. So now all you really need to look at is what I call the inside guys and the outside guys, right? So inside guys is this, right? So 7 times 2, that's going to be 14, right? So that's 14x. And then let's look at outside guys. So outside guys is going to be 3 times minus 6, that's going to be minus 18x. Okay? So then we have 14 minus 18, that's going to be minus 4x. Okay? So which one's our right? Which one's the right answer? Well, D says 9x. We got minus 4x, so I don't think it's D. So if we crossed off A and B and it's not D, yeah, I guess we're left with C, right? So that's what you want. You always want to get this middle guy to match up. That's usually the key to any of these, is figuring out that middle guy. Even if we weren't sure about this part, if we'd have done the middle guy here, we didn't get -4 for either of these either, did we? Plus, we knew if we did this guy here, you're definitely going to get a 6x squared. Okay. So the point of the story is, I mean, you can multiply the whole thing out if you want to, but normally you don't have to. That's the important part. So that can save you some time, and that way you can work on some of the other problems. Okay. So again, that's nothing but FOIL, which of course stands for first terms, outside terms, inside terms, and last terms. FOIL. All right. Questions? Sound good? All right, let's go ahead and check out another one. Okay, so it says, which of the following is the best approximation of the solution of the equation a of x equals b of x? So when we talk about the solution of two functions, what are we talking about? If we have a graph, what are we talking about when we say these two guys are equal to each other? So remember, a of x and b of x is a fancy version of y. So we're looking for the y value of each. Okay, so what you're telling me, Chloe, is 5.5. So you're saying about here, right? But remember, this 5.5 is a y value. So that would be y equals 5.5. So they did that to be tricky, right? So that's a y value. But what you're telling me is that 5.5, these guys are at the same height, right? Okay. So now we need an x value. So at what x value are they both at the same height? So what you've told me in so many words is that we're looking for the place where these guys intersect, right? Which for the y value is about 5.5. But what's the actual x value? Good. Yeah, so basically you're looking for where do these two cross on the x-axis, and that is right around 9. Good. Okay. So anytime they want the solution of two graphed equations, we're talking about the intersection. So the solution is right here. Okay. And that solution is going to be an x value and a y value. In this case, it's going to be 9 and 5.5. Good. And in this case, they want to know the x. Now, if they wanted to know the y, then it would have been 5.5. And of course, they were nasty enough to put that in there, right? Okay. So let's switch gears here. I think that's all the ones I had on here, but I got a bunch of different ones going here as far as these problems. So we're good there. Let's go ahead and save that guy. All right, so maybe we can come up with one more here. This is geometry. There's more geometry. There we go. All right, so we've done some of these, but let's go ahead and maybe do one more of these today, and then we'll call it. Okay. So we've done a bunch of these guys already. We've done a bunch of them, haven't we? Cool. All right, let's check out this one, and that'll probably be it for today. All right, so this is a two-parter. So this is like the intro, and then the next slide will have the actual question. So the points in the graph shows population data in millions of the state of Florida for each decade from 1900 to 2000. So as you see, the population of Florida, boom, going way up, right? All right, so that goes to 2000. Now, amazingly enough, so at 2000, look here, we're about at 18 million, right? We are over 21 million now since 2000. So that's not 100 years, that's only 20 years. So Florida is definitely on an exponential growth rate. I moved down here in the last 20 years, well, more like the last 5 years. Okay. So a lot of people are sick of the north, they're sick of the snow. I know I'm one of them. And some of us definitely love the beach, which is always interesting. The people that actually were born and raised in Florida are like, I don't like the beach. I'm like, what? Excuse me? How can you not like the beach? But that's just me. So here's the function that we're using. Okay. So then let's see what the actual question is. So we're going to have to go to the next slide here. All right. So it says, what is the domain for the graph P of X that is shown? So domain, again, is domain X values or Y values? Yeah, it's X values, right? Okay, so what is the domain? Well, this says X is greater than 0, which, yeah, it looks like X is greater than 0. But we got to look at what they're talking about here, right? It says decades since 1900. So the 0 really represents what? We have to sometimes watch what they're doing as far as scaling this thing, right? So for this graph, 0 really means what? Yeah, it means 1900. And remember, they even told you flat out here, they said Florida each decade from 1900 to 2000, right? So they literally gave you the answer there. So our X value is between 1900 and 2000. That was easy. Okay. So that's the domain on this one. Now, we can't like say all whole numbers because for the simple fact it doesn't cover all whole numbers. It only covers from 1900 to 2000. So that's our guy. So that one was really just that easy. They should all be that easy. But again, it's a lot of mumbo jumbo. I mean, we had to go through all this and this just to get to where we were going. So sometimes the length of the problem, don't let it make you think that it's necessarily a hard problem, because a lot of times it's not. Okay, and in this case, it definitely was not. All right. All right, so on that happy note, we'll go ahead and stop here. I've already got attendance for you guys, so we're good to go. And I will thank you for stopping by. And hopefully we'll see you all tomorrow.